uh, then that is numeric Python. It is very powerful in computation of matrices, linear algebra. So if you see, suppose you want to have, suppose you are doing image processing or you are doing audio processing, okay, and you want to apply some kind of filters, you want to apply wavelet transforms, or you want to apply some kind of transforming images. It is simply a matrix operation. So suppose you want to like there is a value, suppose all the pixels you want to multiply or increase its intensity by 20%. So you can just take that image into a matrix, suppose let's say M, and you multiply with 20%, and immediately all the values in the matrix will get multiplied. So this kind of power is given by NumPy because of the shorthands. Any kind of operations, you want to have inverse, you want to have extract eigenvectors, you want to find out any patterns, that is possible in NumPy. And understand, NumPy is not only going to deal with 2D arrays. Like in pandas, we dealt only with tables, and tables generally have two-dimensional data. But in NumPy, you can have three-dimensional data, four-dimensional, 10, 100 dimension. Even I have seen data of 1 lakh dimensions. They are possible. Like there are some machine learning applications like text mining or something, where we can generate lakhs of dimensions. So so any such kind of data can be dealt by NumPy. Okay, that's how powerful it is. And even if it's not always you require a GPU or something, even with some basic capacities of 4 GB RAM and a i3 processor, you can deal with much more data. Why all this why all this is possible in NumPy and pandas is because in the background we will see, when we will go more into details in the workshop, in the detailed workshop, you will see that how these are linked to very powerful languages which are very close to processors. And because of this, these languages, they enable NumPy and pandas to have very powerful computations. Okay. And like in NumPy, you can have slicing, dicing, mutations, filtering. Like suppose you want to have, just think, on WhatsApp you have a application where you can have a blue filter, red filter. It is just a one line code, okay, in NumPy, that you can apply blue filter or red filter. It's just a value you want to multiply the matrix or image with, and your blue filter or red filter will be applied. So just think, it may be a mesmerizing thing for many guys around you, but as a IT professional, when you learn NumPy, you will understand, oh, it's just a flick of a program where just one line of code, and it turns out have to have a blue filter or gray scale or all those stuff. Okay, any questions?
Actually received quite a few questions, to be honest. We'll take
Yep.
it one at a time. There's one question about what is the future of Python in IoT?
Okay, that's a very good question. See, IoT is based on embedded technologies, where you have very small things or sensors getting in everywhere, and they are sending you data, and you process that data. See, Python, the main feature of Python is it can handle any kind of data, any speed of data. So when we talk about sensors, you're continuously going to get data in IoT. You're going to get continuous data, that is known as like fast data. They rather than big data, they have come up with a terminology, fast data, for IoT. So when we come up with this fast data, you need to process the data in real time, and these libraries in Python can help you doing that. So there is a lot of future of Python in IoT, because like if you see Raspberry Pi, or you see Android, or any kind of devices, embedded devices, they are enabling Python support everywhere. And Python integration, like if you have any kind of sensors, integrating them to servers is very easy in Python. Okay, next.
We have another question from Shyam.
Okay.
He wants to know which is the best algorithm in machine learning or library for high performance computing on large scale in Python.
Okay, I think Sham, this is a bit out of scope of this seminar as such. Maybe later on we can have a personal dialogue. Yeah, Rahul.
Yeah, that's absolutely fine.
Yeah.
Another question is which is the best IDE for Python, universal IDE that is. For those who
Okay.
don't know what IDE is, it is the integrated development environment.
Oh, very nice question, Gunjal. So see, uh, there are lots of IDs, but it depends on like for a starter, I would suggest Jupyter Notebooks or Jupyter Lab. You install Anaconda and you get this. So what you can do is, you know, you can try out a single line of code you can run and try to figure out is there any problem or something in that. And that's why Jupyter Notebooks are very good. But for professionals, suppose you are developing a big project in Python, now there comes like special IDEs like Eclipse or Emacs or many other things, where you should have a support for virtual environments or even Spider for that matter. So PyCharm is also a big thing for developing projects. So what these big IDs they do is that they develop a virtual environment. So what happens if you create new project? So all the libraries related to that particular project are given in that. So kind of Spider or PyCharm, I would suggest for those who are developing big projects. Okay, for newbies or just like researchers who are trying out things, Jupyter notebooks are wonderful. Yes. Any other
Uh,
question?
One last question before we move ahead. It is how text mining is related to NumPy. Adi wants an example for this as well, if possible.
Okay. Yeah, that's a really good question. Because directly if you know about text mining, directly you can't relate it. But see here, once you convert the text mining data in form of like vector space model or those kind of stuff, then it is converted into NumPy array, and then we can have many like kind of manipulations on that. Okay, so yeah, obviously this is a bit specific topic, which maybe we can take later on also. But then, yeah, that's a quick example for it.
Perfect. Thank you. We'll move ahead then.
Yes. So NumPy supports image, video, audio. It's like any data which can fit in a matrix or a n-dimensional array. And I'm not mentioning any data like, see, if we talk about DNA data and if we talk about chemical or protein data and all that stuff can be modeled in NumPy. Okay, because it's just an array, but like a protein sequence is just a sequence. Or just think about this that okay, a time series data, pandas is really good in time series data, and NumPy also you can put the a complete array if you want to deal with the very specific kind of mutations of that data. Okay, uh, so there are lots and lots of data types, not data types, sorry, kinds of data which are supported by NumPy. And specifically, when you want to see the unique functions given by NumPy are very interesting, like broadcasting, filtering, padding. So suppose you want to multiply two vectors or vector into matrix or matrix to vector and all that stuff, scalar multiplications or vector multiplications and any kind of linear algebra, again NumPy comes into picture. Okay, so there you will understand broadcasting is like, suppose there is some variation in the dimensionality that can be bridged using broadcasting. Okay, uh, maybe in detailed workshop we will be going in what is broadcasting and how, because it will require some explicit examples to demonstrate. But understand, these are the functions, or rather there are n number of such functions given by NumPy which makes it very productive, very efficient. And understand one more important thing is the syntaxes of NumPy and pandas, or rather complete Python, are made in a way you don't have to put any loops, or not complex, or like creepy kind of codes. You can come up with very clean codes and very wonderful codes with NumPy and pandas. Okay.